Hello, everyone. On this podcast episode, I'm going to talk about something that that I just realized. And it's something I've been thinking about for a while, but it follows the law of duality, right? It follows the rules of duality. The rules of duality states that when something is too tall, it becomes short. When something moves too fast, it no longer moves. When something moves too slow, it also no longer moves. Or at the same time, it moves too fast. When something is too dense, it becomes light. When something is too light, it becomes dense. When something is too cold, it becomes hot. And when something is too hot, it becomes cold, right? So this logic shows that everything is like, it's like a circle. The world is like a circle. When you move too far away, you come back, when you move in a circle, when you walk too far, right? You end up getting back, to the very beginning again, right? So if you want to walk too far, you become close. If you walk too close, you become far. And following this logic, this duality logic, right? I can give you an example of the earth. When something is dense, right? When something is dense, it becomes rigid and hard, right? When something is light, it is usually free flowing, like gas. Gas is lighter than iron. Iron is dense, and gas is considered light, right? When something is too dense, it becomes light. Water is also what? Light compared to iron, right? So the law of duality states that when something is too dense, it becomes light, and when something is too light, it becomes dense. The earth is very dense, right? The densest part of the earth is the middle. And guess what's going on in the middle of the earth? The middle of the earth is always flowing because what? It is very hot. The middle of the earth is very hot, and because it's very hot, it's supposed to be dense and hard, rigid, right? But because it's too rigid, too dense, it became light instead. It became lighter. It became a free-flowing magma of energy. Just like the sun. Because the sun is so dense, why do you think that, the planets revolve around the sun? The planets revolve around the sun because the sun is very dense. And because the sun is very dense, it is constantly spewing out energy, light energy. The sun became light instead. So the logic applies, the logic works. When something becomes too cold, it becomes hot. Space is very cold. It's the absence of cold. But because it's too cold, the sun exists. The sun exists in space. In the coldest place in the world, there's the sun. The coldest place you expect to, the earth, you think that the coldest place will be the center of the earth, right? The center of the earth is the hottest place on earth. It should be the coldest, right? But it's actually because of, how this world works, how duality works. When something gets too hot, it becomes cold. When something gets too cold, it becomes hot. The earth is solid because it is cold. Something is only solid when it's cold. From its point of view, it's cold. For example, iron is solid at room temperature because iron is cold at room temperature. Ice is solid when you put it in the freezer because ice becomes cold when you put it in the freezer, right? When you heat ice up, it starts to heat up because it becomes liquid, and then it becomes gas, right? But logic shows that if ice gets too cold, it gets too cold, right? If pressure builds up on ice due to its coldness, at the very center of ice, heat will start to radiate. Just like the earth. The earth is very cold. That's why it's solid. The earth is solid is because it's cold. From the point of view of the earth, it is cold. Just like ice is freezing cold. When you freeze ice, it becomes solid, right? When you melt iron, it becomes liquid. If you heat up iron, it becomes liquid. If you heat up ice, it becomes liquid. If you heat up the earth, it becomes liquid. If you cool down the earth, it becomes solid. Yet, because the earth gets too solid, it starts to what? Have the same property as something that shouldn't be solid. That's something that should be hot. When the earth gets too cold, it becomes hot. That's why the center of the earth is filled with magma, because the earth the center of the earth has become too cold. Because it has become too cold, it automatically became hot instead. Because the pressure is too high at this, the pressure at the center of the earth is too great. It no longer has pressure. That's why, at the center of the earth, instead of everything being rigid, everything, the more pressure is applied to something, the more rigid it becomes, right? But because the earth has too much pressure applied to it, the center of the earth has too much pressure applied to it, it no longer takes the same form that it should, a rigid form. It starts to take a flowing form instead. It starts to flow like lava. Likewise, it used to be cold, but because it's too cold at the center of the earth, it ended up becoming hot instead. These two properties are the reason why the center of the earth is hot, and also the reason why the center of the earth is always flowing. Even though the density is very, very high at the center of the earth, which should cause it to make it, the density should make it rigid, but because it's too dense, it's no longer rigid at the center of the earth. It's now flowing energy, just like the sun itself, because the sun's, the gravitational pull, within the sun is too dense. Because the sun is too dense, it's no longer dense. There's always energy flowing from the sun. Yet the sun is the densest place in our solar system. That's why the sun is pulling all the planets. The gravitational pull of the sun is pulling all the planets to the very center of the sun. Yet the sun itself is the lightest place on Earth. It's the lightest place in our solar system. The densest place in our solar system is also the lightest place. Everything in the sun is always flowing. Everything in the sun is plasma. It is always flowing. It never stays still. Yet density itself, when something becomes more dense, logic tells you that when something becomes more dense, it becomes more rigid and less free flowing, right? When something becomes more dense, it becomes more rigid and less free flowing. It doesn't flow as much. The denser water is, the more it congeals and becomes ice. And when you get to a point where, ice becomes too dense, it starts to flow again. It starts to become liquid. It starts to become liquid, and from liquid to gas, from gas to plasma. This world is a world of duality, and it's always weird when I say, when something becomes too tall, it becomes short. But, the examples of it, The entire world works where when something becomes too cold, it becomes hot. When you go too far into the future, you go back into the past. It's weird, right? When you go too far into the future, the logic of duality states that you go right back into the past. The entire world is a massive circle. It works like a massive circle. When you go too far forward, you should end up backwards instead. Do you know what's infinite? A circle is infinite because a circle has infinite sides. Because a circle has infinite sides, a circle has one side or no sides at all. Finite creates infinity. Infinity creates finite. When something is too infinite, it becomes finite. For example, like I stated before in other episodes, between 0 and 1, they're infinite numbers. Because they're infinite numbers, there's 0 and 1. Between 0 and 1, there's 0.1, 0.01, 0.001. It just goes on infinitely. Because there are infinite numbers between 0 and 1, all that infinity comes together to create 1. 1 implies 1 infinity. 2 implies 2 infinity. 3 implies 3 infinity. 4 implies 4 infinity. And all the way to infinity. Infinity creates infinity. Finite creates infinity. Finite creates finite. Infinite creates infinite. Cold creates cold. Hot creates hot. Hot creates cold. Cold creates hot. This world is a very complicated world. But if you want to understand how this works, I've already given the examples before, like I just stated before. And it's always weird when you start to realize that both sides, everything follows the world of dualities, the two extremes of duality end up coming back to exactly the same thing. This is why I say both sides are always the same. It's two sides of the same coin. Positive and negative are two sides of the same coin. Big and small are two sides of the same coin. Or they're two sides of the same magnet. Positive and negative are two sides of the same magnet. It means they're one. Existence and non-existence are two sides of the same magnet. It means they're one. Hot and cold are two sides of the same magnet. It means they're one. Dense and light are two sides of the same magnet. It means they are one. You can't have one without the other. When everything exists, nothing exists. When everything is tall, nothing is tall. When everything is short, nothing is short. This world is very complicated, and I can go back again and explain what I'm trying to say, because I think I didn't fully explain it properly. But when something becomes too dense, it becomes hot, it becomes light instead. When things become too light, they become dense instead. Space itself is a very light place, Space is the lightest place there is, It has the least amount of pressure. Because it has the least amount of pressure, it also has the greatest pressure. Because space has no pressure whatsoever. There's things like Earth and the sun. These things exist in space. It shows that places where there's no pressure, the lightest places on Earth are also the densest places on Earth. The lightest places on Earth is the sun. The lightest places on Earth is what? The black hole. Yet it's also the densest place on Earth. The densest places on Earth is the black hole. Yet, the black hole is the most, a black hole should be the most free-flowing place in the world. Following the laws of duality, just like the sun is always free-flowing, you expect something that's dense to be hard and rigid, right? But when something is dense, it's too dense, it becomes free-flowing like the sun. When too much pressure is applied to something, it no longer has pressure applied to it. When the sun is too, it's too much pressure, at the center of the sun. That's why the sun appears to have no pressure whatsoever. Don't you find it weird? The sun itself, right? Everything is falling into the sun. That's how gravity works. The sun is actively pulling everything into it. Yet the light from the sun keeps touching the earth. And the light, scientists have saying light, say light is the lightest particle. Light is the lightest thing in the world. I think I remember once when, I think I was once told that light is not even it's not even considered a state of matter. It's something even different. Light is so light that it's not even considered light anymore. Light itself is so light that it's not considered light anymore. The sun itself is filled with light, and it's also the densest place in our solar system. The densest place in our solar system is also the lightest. This is why the sun is shining its light, onto every single planet in our solar system. You would think that because the sun is so heavy, so dense, right? It shouldn't be shining any, it's the light from the sun should never escape the sun because the sun is so dense. But it's because the sun is dense. That's why light can escape from it. The densest place on earth is also the lightest place on earth. The lightest place on earth is also the densest place on earth. Because the sun is so dense, it's constantly releasing light as if it isn't dense at all. Because the earth is so dense, it is filled with free-flowing lava. Because the sun is so cold, it is the hottest place in our solar system. The dualities of this world come together as one. You can't have one without the other. Hot and cold come together as one. Right there in the sun, the densest place in our solar system, the place where all planets fall into. We're all slowly revolving around the sun. We're all slowly moving towards the sun. Yet light can always escape the sun. Why can light escape the sun? Because the sun is also the lightest place on earth. No, the lightest place in our solar system. From the perspective of planets, the sun is very dense. From the perspective of the sun is very light. From the perspective of earth, we're not moving at all. We're not considered, we don't feel ourselves moving. The sun is the one that's moving. From the perspective of the sun is standing still. The earth and the planets are the ones revolving around the sun. The sun is not moving at all. Perspective determines what moves and what's not moving. Perspective determines whether the sun is hot or whether the sun is very cold. Perspective determines whether the sun is very dense or whether the sun is very light. From the perspective of Earth or the planets, the sun is very dense. That's why everything is slowly falling into the sun. From the perspective of the sun is very light. That's why light keeps, heat keeps escaping from the sun. Heat keeps escaping from the sun because the sun is very, very light. Gas is always, when something is light, it means the particles inside of it are always moving. That's the definition of light. When something is very light, the gas particles move faster, always moving. When something is very low, I'm always, pinging everywhere. The gas particles are more rigid. They're more enclosed, they don't move as much. The sun is very light from its point of view because the particles inside the sun are constantly flowing. They're constantly moving. That means the sun is the lightest place on earth. The sun is always releasing energy, constantly releasing energy, solar energy to the rest of the world, to the rest of the solar system. Yet, at the same time, it is always pulling the planets towards it. While it is pulling the planets towards it, it is releasing energy at the same time. So it is both light and free flowing, and also very dense. It is both dense and light at the same time. Just like the center of the planet, of our Earth, is both dense and free flowing like magma at the same time. If something gets too hot, it becomes cold. If something gets too cold, it becomes hot. If something gets too tall, it becomes short. If something gets too short, it becomes tall. When something moves too fast, it no longer moves. When something moves too slow, it starts to move. It starts to move fast. This world is a world where, the equal and opposite somehow, end up together as one again. One size, when you go to the extreme of one, you end up on the extreme of the other. So that's it for today's podcast episode. I hope I explained things, in a way you can understand. It's very hard to explain these more, difficult concepts. It's very hard to explain science, especially when, you have to. It's hard to explain the dualities of this world because it's very scientific. You have to have a basic understanding of science to truly understand how the duality of our life, how the duality of the world works. So that's it for today's podcast episode. I'll talk to you guys later. Bye.